Hello everyone, my name is Andrew. Today we'll continue learning Python, and today we'll talk about random and why is it not that random. So let's start. Again, today we'll talk about random in Python and why really random is a pseudo-random in Python or pseudo-random in Python. So why is it not random at all? And before we start, I want to make a simple program. So import random and let's print random.randInteger from 0 to 100. If you don't understand what that means, don't worry. Even if you have no idea about programming, that video may be useful for you, because I have a lot of videos that are really specific and you need to know a lot of stuff in order to follow them. But that video is for everyone, because I'll explain it in very basic terms, and yeah, nothing will happen. So now we can see that you have a program which simply prints for random integers from 0 to 100, and as you can see, every time I run my program, you can see it in the terminal, the integers change. But what is it with random in that program? So as we know, as we can see it right here, that is a random set of integers. But really it's not that random, because it's again a pseudo-random or pseudo-random. Yeah. So that means that our random can be replicated at any point in time. If I want, I can get a random for a specific value, I can get a random for a specific time, and I can get a random for a specific program, if I want to, because that's a pseudo-random. And our random, after a very long period of time, will repeat itself. So for example, if I sit here and watch my random integers for 25,000 hours, I may distinguish some sets of integers, some repetitions. So I can maybe see that something is not that random, or my program is not that random, because again, after 25,000 hours or something like that, a very long amount of time, I'll see that that is a pseudo-random. So there is no like really random integers at all, or random values at all, because in random in Python and in every programming language, because again, it's not just for the Python, but for every programming language, which is not very specific. Like if you have a language at NASA and maybe you use random values, then probably you need really random values. But for every programming language like C++, C, JavaScript, Java, C#, Rust, maybe Go, maybe I don't know. So for every normal programming language, what we have is a seed. So what is a seed? Random.seed is a function in Python that will change our seed, so our random seed, to a value that we wish. So random seed, or seed itself, is a value that is used in order to give out the random values. So seed is an input that our random functions will use in order to give us a random output. And in Python, what we can do is use random.seed function in order to change that seed. So what we can write here is any number, for example 0. Maybe we can even write like hello, I'm not really sure, but yeah, we can write it, any value. So we can write something like 0, and let's start our random. So as you can see, 49, 97, 53, 5. Let's write 1. As you can see, different values. But what if I do not go any further and I stay on random.seed 1? Let's run it again, and again, and again, and again. So as you can see, our values do not change. Okay, if I change my seed, my values will be randomized, but still, they're not randomized at all, because as you can see, I rerun my program many times, and yeah, as you can see, the values do not change. So what does that mean? That really shows us that random.seed is a value that will be used in order to give out the random output. But that value, if it's a constant, and in our case it's a constant, it's just like 2, again, it can change to 3, 4, 5, but if I just leave my program like that, every time it will give me the same set of integers. So as you can see, values do not change. So if our random seed is a constant value that does not change throughout our program or throughout our program executions, so if we execute our program multiple times, the random seed does not change. That means that our random output will be the same. So that really shows us that our random is not that random, because we have a seed that tweaks the values of, that tweaks the output of random module and every function in that module. So yeah, that's just a simple explanation of a random seed. So it's a value that will be used in order to give you your random values. And if you change that value, your output will be different. But if you don't do it, then again, you can really see that there is no real randomized or real there is no real random in any programming language. That's pseudo-random. And how we can, in the beginning of the video, I said that with pseudo-random, we can replicate it. So what do I mean by that? Again, we can replicate it. For example, if I put 5, I can see that, okay, 79, 32, 94, 55. And again, I can replicate it by just leaving my 5 as a random seed. And I can, if you don't know how you can use it, then I can give you an example. A very great example, and I always like to give it out to everyone that I'm talking to about random. So everybody knows about Minecraft the game. So there is a game called Minecraft. Yeah, I think everybody knows about it. And you have worlds, and most importantly, what you have is a seed. So when you create a world in Minecraft, you have a text input which contains a value. And that value is called seed. So what is a seed? Seed, it's, I'm not sure if it's required to be an integer, but it's a value that is used in order to generate your world. And what you can do, again, is if you change a seed, your world will be randomized. So every time you change a seed in Minecraft, your world will be random. So you will spawn in a different location, in a different biome, and so on. However, what you can do is go to the internet and find some cool seeds. For example, a seed with a beautiful valley, or a seed with a beautiful ocean. And what you can do is copy that value and paste it inside of your Minecraft world during your Minecraft world creation. And after that, your Minecraft world will be the same exact copy of the world from which you copied the seed. So what does that mean? Again, Minecraft worlds are randomly generated. However, those worlds are generated using a seed. And if we copy that seed from another person, then we can replicate his or her world. And that's very interesting, because what we can do is replicate anything. So imagine that somebody wants to, oh no, I will not explain, or I will not give you that example just yet, but at the end of the video you'll understand how to read past or how to see the future with random. But now let's talk about how our values, or what's the default value for random seed, because every time I run it, as you can see, it's different. But what's like the value? Where do we store that value? Because if I, for example, do like I equals 0, and you know that all the variables in Python are stored in RAM, as in every other programming language, so I cannot like really have that value anywhere, have my random seed anywhere. But we forget one thing. What's the variable that increases constantly? It's our time. So every second we have less time. Yeah, that's kind of sad, but still every second our time increases. So the time in computer increases. So as you can see now, it's 10:55, 11th of October 2021. What does that mean? That means that tomorrow the time will be different. And if you know, I explained that in one of my previous videos, I think I explained it a year ago or so, but if you know how time is, how we use time in computers, is we simply have an epoch. So epoch is a point in time from which we count our time. It may be very difficult, but what we have is time-to-time function in Python, and it gives us an integer. Well, it's not an integer, but it's a value, a numeric value. And starting from the 1970, the 1st January of 1970, what we have? We have an integer that rises or that increases every second. And with that integer, and knowing that, okay, our epoch started at that point in time. Again, the point in time can be different, but knowing the starting point and the relative amount of time. I do not want to say seconds because we count microseconds and nanoseconds right here, but the relative amount of ticks from that epoch, from that starting point, is our time right now. So again, as you can see, that is the amount of seconds passed from the epoch. If I run my program many times, what you can see is 04, 07, 09, 010, or just 10, 11, 12, 13, 14. So as you can see, the last two values, so the last two, I forgot how they called, but the last two values are rising with every second. Yeah, 27, 28, 29, 30, and so on. So every time our time increases, and that's normal because time moves forward. But that means that we have an integer that we can use as a random, and every time we run our program, our random seed will be different, because if we use time.time as the random seed, that means that every time we run a program we have a different time, so we have a different value for time.time, and what we can do is simply put that time.time right here. Let's import time right here, and after that, if I run my program right now, what you can see, 53, 24, 55, 60, and as you can see, the values change because our time increases. So the output of time.time function increases, and that means that our output changes. So really, we have something like a randomized value, because we have not a random, but we have a different seed for every program execution, and that's really interesting. Why is that interesting? Because let's return to time. I'll comment that out. Let's return to time. What we have in time is a local time function that accepts the amount of seconds. So if I put time.time, again, it accepts the seconds from the epoch, but time.time returns those seconds. Let's run it now. And as you can see, it says time, struct time, and if you don't know about time, struct time class or object, it's like a structure for time representation in time module in Python. And again, I have a very descriptive video about time library in Python, so you can probably watch it. I don't know if it will pop up, if I will not forget about that, but yeah, still, I have it. And I explained everything about epoch, about local time, about all of the other functions, but still, local time gets the amount of seconds from the epoch and converts them to struct time. And time.time returns the amount of seconds. So as you can see, when I passed time.time, so the current time on my system, so 10:59 in my case, well, it's really, really late, but whatever, time.time, inside of local time function, what did I receive as the output? TM year, so year, TM again, it's time, year 2021, 10, 11, 22, 58, 43. I will not say everything because it will be really long, but still you can see that we have 22 hours, so that's 10 p.m. We have 58 minutes. We have the U day is like year day, so how many days passed from the start of the year? 284, so everything is right. And if I put, instead of time.time, I will put the amount of seconds. I can put 0. What does that mean? Start from the point, from the epoch. Start from where you started, start from when you started counting the time. Again, it's very, very complicated and I cannot give you the proper words, but still, start from the concrete point in time when you started counting the time. Again, it's really complicated, but still, you understand. As you can see, if we give out 0 as our input to local time function, what we receive? Struct time, TM year 1970, first month day, for second hour, but I think that's a problem, because second hour, what we can do is use GM time. There are some differences between GM time and local time, and you can know about those differences or get the difference in my time so there are some difference between local time and GM time functions, but if you want to know about those, then watch my video about time module in Python. But still, as you can see, we receive 1970, first month, first day, hour 0, minutes 0, seconds 0, 0 seconds, and so on. So we receive the starting point of time for the computers. And yeah, you can check if your computer runs for the same epoch, but yeah, I'm pretty sure it runs for the same epoch, because 99% of computers right now count their time from that point of time. Well, again, it's really complicated for me to speak about those things, because yeah, you cannot really get the proper words, because you have time on one side and time on the other side. So epoch is the starting point in time from which you count the time. So yeah, what? Okay, but still, you understand me. You understand what I mean? That's the most important thing. So what we can do? Again, GM time from 0 returns the starting point in time. And as you know, random seed by default, I can omit that line, because it literally does the same as not having random seed at all, because random seed in Python by default is your local time. So is the time from the epoch. I'm not sure if they get the local time, but still it's like the time. But what we know is that if I, instead of putting random.seed as any value, and we know that by default it gets at the time, what if I put 0? What does that really mean? That does not mean get me the random for value 0. Well, it means that. But if we think about that the other way, our random seed is our local time by default. And if we change that local time, so we shift it towards the starting point of time, again, but if we put 0, so we put like the start of the epoch, then if someone has ever ran a program that prints 10 random integers from 0 to 100 in Python 3.7 using that specific algorithm, and that person ran that program in 1970s, so on that specific point in time, they would receive that set of integers. So what we did here, we traveled to the past, and that's really interesting, because again, our random seed is a time by default, and if we use 0 as like the starting point, what we can do is we can travel back to the 1970 and get the random output of a specific algorithm. Again, it probably does not matter if you run Python 3.7. I know like I forgot the name of the random algorithm that is used in Python, but it's like something. Oh, really, I forgot the name. Maybe you can see it on the screen right now. Again, if I will not forget about it, but yeah, still. If someone will use that specific algorithm, so the algorithm that is used inside of random.rand integer in Python, on the start of the epoch, so on the 1st January of 1970, he or she will receive that set of integers. So again, what does that mean? That means that what we can do is travel to the future. How we can do that? Let's get our import time and let's print time.time. Let's run it. We can get that integer, or we can get that float value, I guess. And what we can do after that is get gm time just for the comparison, gm time from that point, and after that, let's paste it right here. I'm not pretty sure if we should get gm time or local time, so again, the difference is that local time is your local time, but gm time is the time from Greenwich, so from UTC 0. Let's get our local time, so let's get our local time. And what we can do right here, instead of using like 163, what we can do is change the first value again. How is it called? The first decimal to from 1 to 2, and that means that we'll move to the future, because if you look at local time, it's year 2053, 6 months, day number 20, hour 0, 51 minutes, 58 seconds, and so on. So now we are in the future because we use that value. And that means that if we put the same value as the random, and let's run it, as you can see, the values do not change. So if somebody will ever run a program in Python 3.7, if Python will not change its algorithm, it can be any Python version. So again, if you change your random algorithm, then of course your input will change. But if you still use the same algorithm as we use it right now, so the same algorithm which is used inside of rand integer, and you run your program at that specific point in time, you receive those values. That's really interesting because we already know what the future is like. Because like what we can do is, for example, use import string. String is a verb, or it's a module that contains some useful things for strings in Python. So for example, ASCII lowercase. And what we can do is use print string ASCII lowercase. Let's put random.sample ASCII lowercase, for example, 4. That will give us the 4 random values from ASCII lowercase, and then we need to join it because it will give us random sample returns an array, so a container, and if we want to get it in a string, we will use that. And imagine that there is a program which will give a random username to the user or a random password to the user. That's much more interesting, a random password to the user. And imagine that we know that in how many? In 30 years, oh my god, 2053 is in 30 years. Okay, in 30 years, somebody will access a website that will get a password of 16 integers. So that means, or 16 ASCII lowercase letters. So that means that if that person and that program runs that random password creation algorithm on that specific point in time, what we can do is, again, see the output. So that will be your, so if we run our program, so we get 16 random letters from ASCII lowercase string on that point in time, we receive that no matter what. And that's really interesting because now we can travel to the future. It's really like a theoretical stuff because in order for you to run that program and to hack a password, it can be like, well, there are timing attacks in security. So yeah, there are timing attacks when you can use timing in order to break into systems. But in order for you to get again, you don't know anything about the future. What if a Python will change its algorithm and then your program is useless? But still, what you can do is try to do it. Don't try to hack anyone. It's not great and you're responsible yourself, but still, it's really interesting because what you can do is really go into the future. So in order for you to create something from the future, what you can do is something random from the future. What you can do is really change your seed, because in every programming language, in C, in C++, in C#, in JavaScript, random relies on the time, on your local time. So that means that if you change the seed to the desirable time of yours, then what you can do is look into the future or really read the past. Because if someone created a password on the start of the epoch using Python for some reason, Python 3.7, yeah, for some reason, like 50 years ago, oh my god, 70s were, oh my god, yeah. Time flies fast, I guess. So if somebody created 16 ASCII lowercase sample at the start of the epoch, he or she would receive that string no matter what. So that is really interesting, and that's how random works. Again, it's just a theory, and there are a lot of cool things I can teach you about random. So if you want me to talk about that, leave a comment, and yeah, leave a like, subscribe to my channel. My name is Andrew, thank you for watching, and good luck.